traditional introduction. I always tell classes that they can dance at their desks during that intro, and the Ottawa class just killed it. So way to go, guys. My name is Jesse, and I am with Exploring by the Seat of Your Pants. If you're joining us for the first time today, we are all about bringing conservation, adventure, and science into classrooms around the world. And as December rolls along, I just want to do a special shout out again to all our teachers live and on YouTube today and all our other days. It's been such a thrill having you. I know it's still a weird school year. You guys are coming back for the first time, in some cases in a very long time. And so we really appreciate you joining us as we continue to showcase and celebrate such amazing people and places around the globe. Now, today we are continuing our epic Fisheries and Oceans Canada series. We've talked about whales, we've talked about microbiomes, we've talked about all sorts of really cool topics with a wide array of awesome scientists over the last few weeks. You can check all of those out on our YouTube page. But today we've got a favorite speaker of ours from years past and someone that we've really wanted to bring on. It's been a little bit of a shuffle, so if you made it to this point, thank you for sticking around. This is well worth it. We are joined by Dr. Keystone Stortini, and she is going to talk to us today about her career as a marine biologist, a little bit of the ocean and climate change, and her story embodying what we're all trying to do with these broadcasts, and that is to be inspired by the natural world, to understand some of the plight that it's facing, and to take action accordingly. So Christine's version of that was to become a marine biologist and do all sorts of great work. I hope you guys are as inspired by her as I am. And so without further ado, I'm going to turn it over to Dr. Stortini to blow our minds over the next 20 minutes. Thank you so much for joining us today, and I'm so excited to dive right in.
Thank you. Thank you so much, Jesse, for the wonderful intro. Hey, everyone. I'm Dr. Keystone Stortini. And as Jesse said, I'm a marine biologist working for Fisheries and Oceans Canada. I'm going to chat with you guys a little bit about how it all started for me, you know, where I grew up and how that progressed, how I became a marine biologist, and then a little bit of what I'm working on right now. And then a bit of like the big question, why I keep doing what I'm doing, or why I have developed my career as it has developed. I am having trouble clicking.
That's okay. You were on the next slide. It did work.
Okay, it came back. Okay, so like a lot of you on this call, I actually grew up in an inland place. I grew up in Northern Ontario, a small island in Lake Superior. So I grew up swimming in the lake. I always wanted to be in the water. I was always exploring, opening my eyes under the water, seeing what was down there. And I had a really strong family bonds there. We had a lot of outdoor dinners. And then I went to high school and started learning about the ocean. I took a course called World Issues, and I learned about coral bleaching and about overfishing. And I started to get really curious, and I started to wonder if I could develop a career to help solve some of these problems. So I moved to Halifax, Nova Scotia after high school to go to Dalhousie University to do a Bachelor of Science in Marine Biology. I did the co-op program, so I was able to do some work terms in between school. So it was 4 months of school, 4 months of work, 4 months of school, 4 months of work. So it ended up taking me about 5 years to do my undergraduate program. I also did an honors thesis where I did a research project. So I got one of the co-op jobs that I did was I went to Costa Rica to work with sea turtles, and that was one of the highlights of my life. Really, really amazing experience. I got to experience what it's like to work in the lab, to work in the field, to work with computers. So I got a lot of different experiences, and then I sort of honed in on where my passion lied with my final research project, where I started working with a government scientist and working on marine protected areas and deciding on which boundaries for the design of a new marine protected area would best protect the most vulnerable species to their most imminent threat, which at the time was redfish, and their threat was bottom trawling. And so then I got really into policy, and I decided that that's what I wanted to do. I wanted to do research that directly impacted government policy and the way that we manage our oceans. So I did my PhD researching the ecosystems on offshore banks. And then directly after my PhD, I was lucky enough to get a job with Fisheries and Oceans Canada, first off working on climate change vulnerability assessments for species in the freshwater world, actually, but species at risk. So trying to figure out to what degree climate change was going to be an issue for species at risk from other stressors already. And then I started transitioning into another role where I'm working on marine protected areas again, which is my passion, but particularly integrating climate change considerations into marine protected area design planning and monitoring. So I'm going to go a little bit into these two projects that I've been working on over the past year. So climate change vulnerability assessments, I actually did my master's thesis in 2012 to 2014 on climate change vulnerability assessments. It was a new idea back then, and my vulnerability assessment was one of the first. But now, a lot has, in the time that I did my PhD, which was about 5 years, other people really developed this science of vulnerability assessments and made it even better. And so I've come back into the game and I'm using these new developments of vulnerability assessments. One vulnerability assessment in particular, a colleague of mine, Dan Boyce, has created a global climate change vulnerability assessment for marine species. And I've taken his assessment and adapted it for freshwater, which is an area that is typically lacking in data and work when it comes to specifically in Fisheries and Oceans Canada. So I'm working with some folks that really want to know if our species at risk in the freshwater environment are at risk to climate change, and if so, where are they most vulnerable? And at what point will they become highly vulnerable? So a climate change vulnerability assessment has 3 parts. The first is exposure. So assessing what the magnitude of impact climate change will have on a particular species in an area of interest. So how much habitat will the species lose? When will the habitat in that area become too warm for the species to tolerate it? How fast is the climate changing around that species? So the velocity or the rapidity of climate change in its surrounding environment can be very stressful if it's happening very quickly, right? And then the second component of a vulnerability assessment is sensitivity. So assessing if the species is already at risk. Has its population already been depleted because of something like overfishing? Is it already living close to its upper thermal limit? So is it already stressed by an environment that's becoming very warm? Is it under threat from other stressors? Is the area that it currently lives in highly polluted? Are there road crossings? Things like that. And the third component of a vulnerability assessment is adaptive capacity. Can the species adapt or shift in distribution? So is its current habitat natural and healthy so that if one part of it became too warm for it, could it move to another part? Does the habitat allow for movement? So is it highly connected? And this is really specific to freshwater. Is it connected enough that a species could move from one part of the habitat to another? And can the species move? Is it a fish that can swim, or is it a barnacle that sticks to a rock? So these are the considerations that I am quantifying and then combining to come up with an overall vulnerability score for species in freshwater environment. So my species of interest are Atlantic salmon, American eel, Atlantic whitefish, and striped bass. And this is my area of interest. It's Nova Scotia. And these are the primary watersheds of Nova Scotia that you're seeing in this map. So a primary watershed is an area that has connected waterways. So rivers, lakes, things that are all connected to one water source. So these are the areas that we know Atlantic salmon is present in this primary watershed, but not this one. So I want to see where it is currently present, how vulnerable is it to climate change and other stressors. So like I said, I'm combining information from all of these different components and exposure, sensitivity, and adaptive capacity. I'm mapping them out from low to high vulnerability, and then I'm combining all of this information to come out with an overall vulnerability score under 3 different climate change scenarios. So RCP 2.6, RCP 4.5, and RCP 8.5 are 3 different emissions scenarios from the International Panel for Climate Change. RCP 2.6 is our scenario where we significantly reduce emissions. So we do our best to try to combat climate change. RCP 4.5 is where we reduce emissions, but not as much to the 2.6 level. RCP 8.5 is that we continue on our the way that we're doing things right now, where we're increasing emissions. So basically, RCP 8.5 is our worst case scenario. So I'm assessing vulnerability within each of these scenarios to get an idea of, okay, what if we reduce our emissions? What will that mean for American eel? What if we keep going in the route that we're going? What does that mean for American eel? And so I've done this for each of my species of interest, including Atlantic salmon, which has a really active research program going on right now. So I'm really hoping that my results will help with management programs for Atlantic salmon. Then in the end, I'm hoping to combine the information from the freshwater realm with vulnerability results from Dan Boyce, who created the vulnerability assessment for the marine realm, combine the results so we can see where these species are most vulnerable in the freshwater realm as well as the marine realm, and use that information to create better management programs. That kind of comes into my second job. So the climate change vulnerability assessment work I started last year in December. So it was a year ago, and I've been transitioning into this new role working with marine protected areas since about June. Well, actually, no, September. It hasn't been that long. So what I'm doing now is we have this network of marine protected areas planned for the Scotian Shelf. So that's the area off of Nova Scotia. And these sites were proposed, although not legally proposed. This is a draft design that still needs to undergo consultations with fishermen and other community members and stakeholders, what we call them, people who have a stake in the marine environment. These areas were chosen based on if they have depleted species at risk, have important habitat, and then having the combination of all of these different areas within the network means that there's a representative example of each different type of habitat, each different type of ecosystem. So we want to protect everything. We want to protect all our different ecosystems so that we protect all our different types of species. So my job now is to use information like climate change vulnerability assessments to see how well this current design does at protecting areas of high vulnerability, medium vulnerability, low vulnerability, future habitat of species at risk, these sorts of considerations. It's still in the early stages, but I have a really great group of colleagues that are working on these issues with me. And we're having a lot of meetings deciding on what sort of information we want to include, what sort of spatial data layers we want to map out to assess this design and then move forward. Okay, so that's what I'm working on. And I wanted to go a little bit into the why. So why do I do what I do? It's because I really genuinely love the ocean. And I think that came from where I grew up on a lake swimming and my love for water in general. But then once I discovered the ocean and how big it is and how powerful it is and how beautiful it is, and then I started surfing and I started scuba diving, and I genuinely love the ocean. And so I want to do my part towards protecting it. And the ocean is full of beautiful, strange, important, and interesting creatures and ecosystems that deserve our protection, that not only inspire us and are amazing to explore and to look at and to learn about, but also are very important for our own survival. So things like kelp forests and eelgrass beds, these types of ecosystems that they sequester carbon, they take carbon dioxide out of the atmosphere and give us the oxygen that we breathe. And so many healthy ecosystems provide us with the food that we eat and medicines. And so, yeah, that's why I do what I do. So the ocean covers 71% of the Earth. It contains 97% of the Earth's water, 70% of the oxygen in the atmosphere, 70% of the oxygen that we breathe comes from the ocean. 15% of our global protein comes from the ocean. And because it covers such a large proportion of our planet, it influences both the weather and the climate of our planet. And it stores solar radiation, and it helps to distribute heat around the globe because of its circulation patterns. So it's very, very important to keep this part of our planet healthy. It also gives us a place to feel connected to nature and at peace, unlike any other place on the planet. I don't know about you, but when I look at the ocean, even on a video, and hear the waves rolling and look at the horizon, it makes me feel more at peace. So I think that's also very important. So this is sort of my sign-off message. I chose the direct route to become a marine biologist and work in marine conservation for the federal government. I'm very, very happy with my job. I love my job, and I'm very proud of it. But every single person on this earth is connected to the ocean in one way or another, and every single action impacts the ocean and every other person on this planet that is connected to it. So no matter what you choose to do with your career, with your life, I hope that you find a way to connect with the ocean and be kind to it and be a part of the solution. Because no matter what job you choose to take, there will be some connection. There will be something that you can do to help be a part of the solution. So thank you. I'm ready for questions.
That was fantastic. What a fun program. If you want to come out of screen share so you can see us and have a bit of a conversation, that would be awesome. But yeah, we've got a whole whack of classes joining us on YouTube as well. We had a couple join us after we got underway here on StreamYard. So many of you are here today and welcome in. So Miss Robinson, Miss Bullock's class, Miss Nagel, Miss Bowers, Miss Alexander, all sorts of great teachers today. I'm excited to dive in with questions. Now, while our live classes are sort of letting those thoughts percolate, I will take a quick question from our friends on YouTube. So Miss Bowers' class, Samuel wants to know, is there a specific species or group of species that's most vulnerable in, they mentioned freshwater, but the oceans, anything that jumps out in terms of most vulnerable?
Right, yeah. Well, typically species that are more cold water adapted tend to be more vulnerable when they're at where they're at their closest limit to their upper thermal tolerance range. So if you're a cold water species and you're at your southern limit, which is where the warm water is coming up from, you're more at risk. You're more at risk to disappearing from that particular area. And if you're so for marine species, that means typically moving north, moving away from the warm water. And that can be a stressful situation. So that can cause additional stress to a population that's already under stress from overfishing, pollution, any other stressors. In the freshwater environment, it's a little bit of a different story because some of these species or some of these populations, like Atlantic salmon, they live in very specific watersheds, and they tend to go back to that particular watershed every single year, and they will choose a specific river to go back to, and there's very little evidence that they move from one river to another, let alone to a completely different watershed. So those species are highly at risk because we don't know if they're going to adapt by moving. So they might be forced to experience this warming, and that can have really severe impacts on their physiology. They might end up not reproducing as much as they used to. So those are the different types of concerns.
Let's head to our Ottawa class. We had a class, Brave a Snowstorm, to come join us today. So if you guys want to unmute your mic, I'll bring you guys in. and take us away with our first live question. Hey, guys.
Oh, great. Well, Edward, do you want to ask your question, or do you want me to just ask it?
Sure, I can ask.
Okay, speak loud.
Like, how are you supposed to protect it if there's going to be pollution there?
Yeah. So my class spoke a lot about the fossil fuel industry, and we're worried about the freshwater stocks, and we're wondering what can we do to protect it?
Nice.
What can you do to protect it?
Yeah, well, and specifically with regards to pollution. So they're worried about oil, they're worried about pollution in the water. What can their class do to take action?
Okay, all right. Well, there's plastic pollution is one of the many different types of pollution that can cause issues in the freshwater and marine world. So if you can clean up plastic wherever you see it close to waterways, that can be incredibly helpful. Don't litter. Try to use less plastic, or encourage other people around you to use less plastic, because the more of us that are taking plastic out of the environment and not putting it into the environment, the better. You can petition for fossil fuel reductions in your community. You can petition for proper waste management in your community. You can petition for certain companies that work in your area to use less plastic. And get involved in climate, like the climate change protests and stuff like that.
I was going to say, I'm really glad we got this question. We usually get it sort of cap off a broadcast, but you've touched upon everything that we always feature in these programs. You know, don't waste as a general concept, whether that's plastic or food or emissions, what have you.
Yeah.
Educate yourselves and tell your friends and family. It makes a big difference. And really, you know, the nice thing about this generation that's joining in our classes today is that they live and breathe this stuff. You guys all know the science. You're all so vested. I mean, everyone thought it was going to be our generation, and it's you guys. You guys lead these marches of, 500,000 kids. You guys are really active, and it's amazing to see. So on the contrary, however we can support you guys and your great work, it's always a great thing. So thanks for that question, guys. All right, I'm going to head to Miss Parrish's class. They're joining us in Petrolia. If you guys want to unmute your mic, you're good to go. And then I'll head to Miss Strickland joining us in Georgia. So Miss Parrish, come on in. Hey, guys, 6-7s. We have to unmute first. There we are.
Is there a special species that you like, or that is a really weird species that's endangered?
Nice. Your favorite species, weirdest thing? What do you think?
Oh my gosh, I have so many. I mean, my favorite weird species would probably be the batfish. I think I put a picture of it on one of my slides. The fish with the red lips. It's just the strangest thing I've ever seen, and I've been obsessed with it ever since I saw one. My favorite species that's endangered. Okay. I mean, sharks in general, I've been really fascinated with, and about 90% of all the sharks on this planet are gone compared to historical population sizes. So I would say sharks in general. And I've had a chance to scuba dive with them, and they're just magnificent creatures. And the way they look at you, you realize that they're a lot smarter than you think. And yeah, I'd say sharks.
I love that. We have a question in our YouTube about sharks too, so I'm glad you covered that. And I want to note for all our classes, in fact, I think all of our classes today fit this bill. Once you're 8, you can start on the path to becoming a scuba diver. So it's called Bubble Maker in Patty. It's an amazing program. I got my license a couple of years ago. It's like black magic. You can breathe underwater. It's amazing. So I really encourage all our classes to look into that, because it opens up 70% of the world to you that was otherwise inaccessible just by getting your scuba license. So it's really, really cool stuff. You can end up as cool as 15. Let's head to Miss Strickland's class. Joining us in Catala, Creekside. Welcome in, guys. Hey.
Say hey.
Do you have any questions? You are representing the entire United States in this program right now, so no pressure at all. But if you have any questions for Christine, you're good to go.
All right, go ahead, Roy.
What species do you think you save more than the others?
Ooh, what do you save more than the others with the work you do?
I think the majority of my work is around marine fish and fish ecosystems, because that's what we have a lot of data on for our particular region. And that's the sort of data that I work on, is data on fish and their communities. And we deal a lot with marine protected areas. There's a lot of conversations back and forth with fishermen. So, and one of the species that I've studied the most would be Atlantic cod, because its population was severely depleted in the 1990s because of overfishing. And our region's been trying to properly manage our fisheries to help that population to increase. That's not directly, I don't work directly with Atlantic cod, but a lot of the work that we do is in the hopes that that particular species might increase in abundance.
Yeah, I do encourage our classes, look up the cod just in general as a fish. They're really interesting and delightful looking fish, and it's sort of the iconic Canadian fisheries management story, certainly on the east coast of the country. So very, very cool, guys. I'm going to head to Ms. Robinson and Ms. Bullock live in just a second. I want to take this great question from Nikita in Ms. Nagel's class. They want to know, how long do you have to be in school to be a marine biologist?
Well, it depends. I mean, you don't necessarily, if you want to get into something like documentary filmmaking, spreading awareness, public outreach, you don't need to be in school for very long to do that. You need a basic understanding of marine biology and conservation. And so you don't necessarily need a university degree to do that. But if you wanted to work for a nonprofit and do conservation work, you would need at least a Bachelor of Science, which is 4 to 5 years, depending on if you do co-op or an honors thesis. And a master's degree then takes 2 years. So that's about 7. If you want to work as a research scientist, which is what I do, then you also need a PhD. So that's 5 years for your undergrad, then 2 for a master's, and then 4 to 5 for your PhD. Yeah, and so you don't need it to work in the government either. You can. I have a lot of colleagues that just have their master's degrees and still do very important work. So
I just have a bachelor's degree and I love it. So I do want to highlight for our student friends, because I mean, the teachers that have worked with me before have had this as a familiar refrain for me. But if you're in grade 3, the concept of 9 years of school and then an additional like 10 plus years after that is very scary and daunting. But you know what? At the end of that, you end up really young and you get an opportunity to work in exactly what you want to work in, where you get to go to amazing places, work with amazing people around the world. So it really is a dream job in a lot of ways. It's not for everyone by any means, but there's a lot of opportunities in the science fields now, and it's a really exciting time. And frankly, by the time you get to grade 12, it doesn't seem as daunting anymore. So
yeah, and I think like the thing is also, while you're going through the schooling, you're having all of these experiences while you're in school, so you don't really think about how much longer. And like when I started my master's, I think I was saying in my mind, oh, I'm not going to do my PhD. Like that's too much. I'm done with school. But then an opportunity arose. It was very interesting, and it just sort of like flowed. And it doesn't really feel like school when you're doing something that you find interesting. So.
Well, again, I'm always glad when we get that message, and thank you for that for all our students. Again, we got you high schoolers today in on YouTube, and it's nice to have that level of encouragement. Let's head to Petawawa. Ms. Robinson's grade 7s. Come on in, and we'll go to Ms. Bullock's in a second. Hey, guys.
Hi.
Hello.
What do you find is the hardest marine mammal to work with?
The hardest marine mammal to work with? Well, I haven't really worked with marine mammals, but I have heard that it's difficult to study some whale species because they live really far from the coast and they dive really, really deep. So you need a lot of equipment to listen to their sounds. Like the northern bottlenose whale, it lives in one particular region, off of Nova Scotia, the Gully. It's actually a marine protected area. It's a submarine canyon, and it goes down thousands and thousands of meters. And these whales dive that deep to catch their food, which is squid. but yeah, I actually don't study marine mammals, but I am fascinated by it, and I have a lot of colleagues that work with them. So
We've had a few programs on marine mammals in this broadcast series with Fisheries and Oceans, but I mean,
yeah.
I love this idea. So this is the thing with field work, is that you never really know what you're going to get. So you've gone out, you've flown from wherever you start to the east coast of Canada, you get on a boat, you go out several hours into the ocean, you see your animal for 2 seconds, and then it dives to like 3,000 feet, and it pops up 10 kilometers away, and you're like, oh man, that's a bummer. So it can be very tricky. It's not easy, and sometimes you have to do gross things. We've had people on talking about getting snot from whales, where they've got like a big catcher hanging it over the snot popping up. So if snot and animals disappearing is not for you, then maybe not the marine whale thing, but lots of other cool opportunities. Great question, guys. All right, Ms. Bullocks, Creekside, come on back in and unmute that mic and take us away. Hey, guys.
Yep.
Okay. Are you part of building new technologies to go down to places like the Mariana Trench? And if not, what technologies do you use?
What cool technologies, Christine? Any cool things? You going into trenches? Are you exploring new frontiers with epic tech? What's going on?
I'm not. No. The work that I do is I use data that other people collect from. They go out on a boat and they take trawl samples of fish and invertebrates, and then I use those data to do my analyses on a computer using mapping programs. So I guess, I mean, new technology. I'm constantly using new computer programs to analyze my data and do statistical analyses and mapping. And this is an area that's always improving and always building. So, but nothing out in the field. I don't do very much field work.
We had a dinosaur guy on the other day talking about them, and he's like, I'm not a paleontologist. I want to start by saying this because I don't want to get dusty and dirty. I like to have cool fossils with me in a room beside me. So, yeah. Great question, guys. All right, Christine, do you have time for another round of questions with our live classes?
Yeah, sure. Yep.
Let's head back to our Ottawa friends. If you guys want to unmute, you're good to go. Everybody.
I have a student en route. Come on, buddy.
Run.
Only 10 to keep track of. Here you go, Abdu.
Which animal can go in the deepest in the dark sea?
Ooh, we've entered in the dark marine biology section of the program, Christine.
Is this so sorry, the animal that can dive the deepest or the animal that lives the deepest?
Either one. Tell us both.
I actually don't know which. It's a whale, definitely. One of the whales dives incredibly deep to catch its food. I know the northern bottlenose whale, like I was saying, dives thousands of meters down in the gully marine protected area to get squid. I'm not sure. It could be the northern bottlenose whale, but probably not. There's got to be another whale that dives deeper than that. And yeah, I don't study the deep sea, but sorry.
So on the bottom, I was just going to say for our folks, if you do want to check out bottom feeding stuff, Dr. Diva Amon, does as a deep sea specialist, and she's been on this broadcast before if you want to see some of her stuff. But I encourage all of our classes to look up the tripod fish. I'm going to put this in the banner for you all. It's the freakiest thing. They found this thing at I think over 20,000 feet down, and it's crazy and really weird looking. But yes, we don't really know much about the deep sea. That's the cool thing about it, is that we've explored the moon and Mars more than we've explored the deep oceans of this planet, which is wild.
There's some really cool animals down there.
Every time we go, we discover new things, which I think is one of the coolest things about it, is that literally, if they send a submersible down, robot or person or otherwise, there's always new discoveries, which is the coolest thing in the oceans in general. Anyway, very cool stuff. We could nerd out all day about that.
Yeah.
Let's head to Creekside again, Miss Strickland's class. Come on in, guys, and take us away.
All right, I have one student who would like to ask a question. Let's see, where did she go?
Where did she go?
I don't know. Where is she? Oh, okay, I'm sorry. Go ahead.
I was wondering if you've ever studied a fish that's now extinct.
Studied anything that's now extinct?
No, I haven't studied anything that's now extinct, but there used to be walruses in Nova Scotia, and there aren't anymore because it became too warm, not enough ice, and they were hunted a bit too much. I read a book also called The Song of the Dodo. And I mean, it's pretty high level, but maybe any of the high school kids that are on the line might want to read it. It's all about the history of things that have gone extinct, and why, mostly because of humans. That's an interesting, really, really interesting book. But no, I personally haven't studied anything that's gone extinct. There used to be also something that I learned while doing some talks about the Arctic ecosystem is that, we all know that there's penguins in the Antarctic, so in the southern polar cap. There used to be this animal called the auk that was like a really large penguin that lived in the Arctic, but is now extinct. And I didn't know that until about last year.
I can attest to the fact that Song of the Dodo is a beautiful book. The Sixth Extinction is another great one for high schoolers. And for younger kids, I think one of the most beautiful books ever done on this is called A Gap in Nature by Tim Flannery. So A Gap in Nature literally goes through a lot of the birds and the mammals that we have wiped out over the past few hundred years and has beautiful images of them. So it sort of highlights the loss of these creatures. It is a distressing time in a lot of ways to be on the planet. We are having a big impact on a lot of species. It's really great that there are so many scientists working to conserve wildlife, and there's a lot of positive good being done. But for all of our classes, if you want to check out A Gap in Nature, it'll probably be at your local public library. It was briefly very, very popular, and I encourage you to see that because it's a beautiful read. Great question, guys. All right, a few more till we wrap up. Time flies and you're having fun. Miss Parrish's class, if you guys want to come back in, you're good to go. And unmute that mic and take us away.
How long have you been doing your job for?
How long have I been doing my job for?
Yeah.
Well, I mean, I've been working with Fisheries and Oceans Canada on a lot of different projects for the past 12 years because I did my honors thesis on marine protected areas with Fisheries and Oceans Canada. Then I did my master's thesis with Fisheries and Oceans Canada, looking at developing a climate change vulnerability assessment in the hopes that it would help marine protected area design. And then I did I did a couple of contracts in between my master's and my PhD on climate change distribution modeling. So predicting where species would move to because of climate change. And then I did my PhD again with a Fisheries and Oceans scientist. And then I've been working doing contracts or short term positions with DFO since last year, so about a year. I've been in my current position working specifically with climate change and marine protected areas in the group that I'm currently working with since September.
Ooh, that's exciting, pretty new.
Yeah.
I like that you included your school in that. So this is something that's worth noting for our classes. Right now, when you're in school, you're doing school. Once you end up in, degree programs, bachelor's, master's, PhD, you're doing the work ultimately that you're going to be doing, certainly the later degrees. And so that's a really nice bonus is that you get to start doing that, working with active scientists and sort of excelling in that way.
Yeah.
We've got two more live questions coming up in a minute. And I love these questions coming in on the chat. But first, from YouTube, from Miss Alexander's class at Westminster Ponds, what's the biggest wave you surfed?
Okay, I think I went out on a day that was calling for 8-foot waves. I think that the wave I was on was 8 feet because it was terrifying.
50 feet. It was 50 feet, I think. That's what I get the feeling. Was it? So you did it though? Like you did the whole wave? Did you crash? Did you like?
No, I rode it. I think it was a really big day and it was a bit choppy. And so it took me a while to get to my feet. So I remember being on it and being like, oh my God, this is the biggest wave I've ever been on and being a little bit scared. And I was like slowly getting to my feet. And then I rode it. I mean, it wasn't like a long ride, but it was, I think, about 8 feet and definitely an adrenaline rush.
That's a very big wave. Sounds tinier than it is, I assure you, kids. So I know I've got some kids on the east coast of the U.S. Of course, you can surf places there. Lake Erie for our Ontario classes. There are places to surf, not with 8-foot waves, but that's probably not a good place to start anyway. So good for you.
And Lake Ontario too.
Whereabouts?
So in Scarborough, there's there's that park. It's Bluff, the Bluffers Park, the Bluffs. Yeah, there's waves there.
Okay, this is very nerdy. We're getting very specific. I like it though. Christine, let's head to Miss Robinson's class, and Miss Bullock, you guys had a great question in the chat. We'll wrap up with that one in a minute, but come on in, Miss Robinson.
What is the most important animal to the ecosystem in the area?
The most important, I don't think we can really say one animal is the most important. Because it's an ecosystem. Every animal, feeds on another animal that feeds on another animal, and there are plants that provide oxygen for the ecosystem. So, I mean, it's all a functioning community. We can't really say one animal is more important than another.
Yeah. I think that, honestly, it's a really important way of looking at the natural world. I guess some of our students might be familiar with the idea of keystone species, where some species do have outsized impact. In this specific case, that might not exist there. But in general, the holistic view is a good one, and I think we can instill that in all our kids watching today. So that's great.
Yeah.
This first class, the question you had in the chat, that second one was great. Come on in, unmute your mic, and you can wrap us up with that. Hey, guys. I love the astronaut in the corner of the room, by the way. That's amazing. Unmute, though. There you go.
Have y'all ever worked with animals that most people haven't seen in the world?
I guess so. I mean, a lot of the fish that I study, I've shown to my family members, and they've been like, "Whoa, I've never seen anything like that before." There's a fish off our region, off of Nova Scotia, called the Atlantic wolffish. It's a species at risk, and it lives in the very deep, deep ocean under rocks. And fishermen would know about it because sometimes they accidentally end up in nets. But they're very, look it up. They're very strange looking animals. And we have these skinny little fish that come up into our region called alligator fish. And I don't think anyone would have seen those in their daily lives. So if you look up fish of Nova Scotia, you'll see a lot of strange things.
The wolffish are really cool. I used to work at Ripley's Aquarium. They have some wolffish there. They are a wild animal. They're really, really cool. So I do encourage classes to check them out. Christine, this has been so much fun. Thank you so much for sharing your expertise with us today and hopefully inspiring a whole bunch of students. Classes, I know we've had a whole bunch of you guys live and on YouTube, so thank you for your enthusiasm and braving that blizzard to come today and our Ottawa class cases. Dr. Stortini, what we do to end every broadcast, I'm going to bring in all our teacher friends to say a big thank you and farewell. So, Ms. Strickland's class, our Ottawa group, Ms. Parrish, Ms. Robinson, and Ms. Bullock, unmute your mics and join me. Thank you so much. Stick around when we're done. We'll have a little chat.